Hey guys, today we're going to be talking about vector and scalar quantities. Vector, spelled like that, and scalar quantities. Sorry for the messy handwriting, still working on it, but we have kind of a comparison table here. So the first thing you need to know about a vector quantity, the basic definition and the really soul of it, is that it has both a magnitude, which can be thought of as, size or amount, and it also has a direction, which is key. Direction is the very important part of this definition. Now, if we go over here to scalar, we'll see that it has a magnitude. A scalar quantity does have a magnitude or size, but it does not have a direction. It does not have a direction. It's kind of an equal sign with a slash through it, not equal to direction, okay? No direction, okay? So that's something key. Scalar quantities have no direction. So if we look kind of at an example here, I'll kind of clear some space in this corner. If we look at an example, and I have a, actually, you know what? Let me just clear the page real quick. Oops. Good, nice new black palette. Okay, I don't know what that's doing there. I guess I accidentally swiped it. Okay, so let's say we have a plane, right? Okay, so I have this plane. It'll be a not a great drawing of a plane, but it's the best that you. Okay, that's just a terrible plane, but it's the best you're gonna get. And let's say it's going, kind of looks like a platypus, but let's say it's going from Los Angeles to San Francisco Airport. So this is its trek. This is its journey. And you say that, gosh, I have no idea how great this distance is. So I could be totally off. I mean, I'm not gonna make any real assumption, but obviously it's not this, but let's say for the simplicity of this lesson, let's call it 10 miles, okay? It's obviously not 10 miles, but let's call it 10 miles. Now, if someone were to say, I took a plane ride, and the plane ride was 10 miles long, okay? They gave you a magnitude, right? You can think of 10 miles. 10 miles is a magnitude. So it's a size. It's the amount that it was traveled. So when we hear that it was 10 miles, we need to think scalar. Scalar, it's a scalar quantity when they say that. But then if we look back at our definition of vector quantity, and they tell us, I took a plane ride from Los Angeles to San Francisco, and it was northbound, and it was 10 miles long. So now we have a direction. We have north. It was going in the northern direction. So now we can think of that as a vector quantity, right? Vector. So when we're told 10 miles, that's scalar. But when we're told, conveniently, when we're told 10 miles north, that's vector. That's kind of how you can think of it. Magnitude only here, scalar. Direction, vector, okay? So that's a good way to think of it. Think of LA to San Francisco, okay? And now we're gonna go back, and we're not go back, sorry, but we're gonna talk about solving for vectors, which may sound a little complicated because you hear solving and you think math, but really it's very simple. So let's bring back our plane here. Let's bring back the plane, okay? Oh wow, that was just awful. Let's go back to the plane idea. Okay, just a rough sketch of the plane, okay? So let's say the plane has a velocity. Sorry, that was a bad term. This has a speed. Actually, velocity is a good term. Never mind. This has a speed of 50 miles per hour. Okay, in the northern direction, right? It's going north, okay? Now let's say it gets a headwind. If you don't know what headwind is, it's wind that kind of it opposes the plane. It goes in the opposite direction, kind of pushing it back. Now let's say we get a headwind, a vicious headwind of 25 miles per hour, okay? Miles per hour in the southern direction. So we have two vector quantities here. Now one might ask, okay, well, what's the resulting vector quantity? How do I know how fast the plane is going to be going after this headwind of 25 miles per hour, after all this wind is hitting it, in the face right here? How do we know how fast it's going to be moving? Well, it's so simple, it'll blow your mind how simple it is. So we take the original velocity of the object in question, which is the plane, so we're going to go 50 miles per hour. And since it's directly opposing it in the southern direction, and this is northern, since it's directly opposing it, we simply subtract miles per hour, and we get a resultant of 25 miles per hour. That's how fast the plane will be moving after this strong, vicious headwind. So now I'm going to go into something a little more complicated. Well, it's not to scare you. It's more complicated than that, but it is still very basic, if I do say so myself. Let's say we have the same plane, our friend the plane here, right? And wow, it changes every time, doesn't it? The plane is not very consistent. My drawing skills aren't very consistent. Okay, so now let's say let's keep, that's a good number. Actually, 50 is a tough number for this one. Let's take 5. Okay, let's say that he's moving at 5 miles per hour. A respectable pace in the northern direction. Now let's say it gets a vicious wind from the side, okay? It's hitting him from the side over here. It's like, okay? Sound effects. And we want to know, okay, well, is it going to be pushed off? I mean, obviously it's going to be pushed off its path a little bit, but is it going to, in the end, will it speed up or slow down? Well, let's figure it out. So we can actually draw this the vector quantity of the wind like that. See, it's moving in this direction. It's actually, you can think of it as a right angle to the direction of the plane. Yeah, you actually must think of it that way, as a right angle to the direction of the plane for this to work. Now, I'm sure that you guys have, if you've had basic algebra, you're familiar with, basic geometry, you're familiar with Pythagorean theorem, the Pythagorean theorem, and that's what we use to find this, to find the resulting velocity vector, which is this guy. Okay, so Pythagorean theorem says that a squared plus b squared is equal to c squared. Okay, so now we want to assume that the original velocity vector in the northern direction is the a term, and the wind opposing it at a right angle is the b term. And now we can just, oh, I'm sorry, I did not give the b a magnitude. It is, let's call it 10 miles per hour in the easterly direction, east, all right, it's going east. So now we'll go back to our little Pythagorean theorem here, and we plug in numbers. We take 5 squared plus 10 squared is equal to c squared. And we move over, we get 25, right? 25 here plus 100. So it's 125 is equal to c squared. And we don't want c squared, though. We don't want, this is c. This is the c term here, this guy. But we don't want c squared. We want c. So pretty easy to solve for that, c squared. So then you just take root 125 is equal to c. That could be, since 125 is not a perfect square, that would be an acceptable answer. Root 125 is the velocity here in the, now, and so you can take that to your calculator and do square root of 125, and you'd get a number. You'd get an exact magnitude. But now the last thing I want to talk about is we have to think, we have to plug in here, we have to look back. Okay, we have a northern and we have an eastern. Now this direction, what direction is it? Well, it's quite simple, northeastern. It's heading root 125 in the northeasterly direction. Now that's your final answer, really. And see you guys later.